Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll continue Class 15 on correlation and categorical contingency tables. Last time we finished the correlation portion of the assignment, and in this video, we'll finish the categorical part. So as we discussed last time, this is in part of your project. So we'll go over to our studio, and I'm already down at class 15, and last time we covered part 1 for the correlation, and now we will cover part 2. So in this part we are looking at categorical variables and interpreting their proportions. Okay, so we want to get a frequency table with proportions, plot them, and then interpret them. And you need at least 2 variables, but you could have 3. I'm going to show you an example with 3 variables, but don't feel like you need to have that many. All right, so I'm going to scroll down to that area. And I did a little sneaky thing. I went away and I put this code in here. But I'm going to walk you through what this code is and where to get it so that you can do this yourself. So in a previous assignment on the website, we looked at the contingency tables, class 14. And if we look in the RMD file, the R Markdown file, I start by reading the data set in, making sure that I've got factor variables. So in this case we had gender, acceptance, and school. And we created a table. That's what this does right here. And then we plotted that table. So all I've done really is I've come here and I've copied this hunk of code and then pasted it and then put my own variables in. Alright, so I'm starting with, let's look at the table first. Starting with my data set, Nisark sub, I'm going to group by, and I'm putting these in the order of the hierarchy from sort of the highest hierarchy to the lowest. So I'm interested in proportions of people who are either nicotine dependent or not nicotine dependent. So that's the variable that comes last. How you sort the variables previous to this doesn't really matter, whether you put depression first or sex first. But my thinking here is that I want to know for females who are depressed, do their nicotine dependence differ from females who are not depressed? I hope I said that right. I basically want to compare the nicotine dependence between females who are depressed or not depressed. Okay, so I would start with my data set. I group by the variables that I care about, and then I summarize, and this summary is going to count up how many. So the n function just counts how many. So the group by takes the data and it partitions it into groups. So we've got sex, male, female, we've got depression, yes, no, we've got nicotine dependence, yes, no. So we have 2 by 2 by 2, that's 8 ways that we can, 8 sets of our data. And for each of those subsets, I'm going to count up how many, and then once I've summarized, the summary actually reduces the grouping hierarchy by 1 because it summarizes by the last variable. Anyway, so then after you come out of the summarized variable, or summarized function, the data now are only grouped by all the previous levels of the hierarchy, but not the last one. Anyway, so that's sort of helpful because then I want to calculate the proportion within each sex and depression category, the proportion of people who are nicotine dependent or not. And so this proportion just takes frequency divided by the total of the 2 groups of nicotine dependent, and then rounds that to 3 digits. And then finally I ungroup that I assign it to this variable, which is a tab for table, and then I did SDN for sex, depression, nicotine. So if we run all of this, oops, not that much. Okay, and then take a look at that object, we get the following table. Okay, so we have sex in this column, female or male. We have depression, no, yes, no, yes. And we have nicotine dependence, yes, no, yes, no, yes, no, yes, no. And we have all those frequencies and these proportions sum to 1 for each combination of all the nicotine dependence. That's the last level of the group by hierarchy. So the 7.6% and the 92.4%, those sum to 100%. And the one thing that is in addition here, notice I've got this knitter table. So it's pretty neat. You can make something that looks a little more like a table. It adds all these lines in there. And I believe it's going to make a nice HTML table as well when we print this. In fact, the first time we knit it, let me show you both versions, just so you can see what this function does. So within knitter, right? Knitter is the package that allows us to put these code chunks in with our prose writing, and it computes the results in the code chunks and incorporates that into a long document. In the knitter package, there's a function called cable, which is really just a way of making tables, and the K is from knitter. So instead of a table, it's a cable. So it's going to give us a nicer formatted table. All right, so we're going to come back to that in a second. In fact, let's go ahead and knit it while I discuss the plot. So the plot I also took directly from the previous assignment, from the categorical contingency tables section, and we're going to get a table, or rather a plot, that looks a bit like this. Okay, actually I think the one that I'm doing looks like this. Okay, so you've got, in this case, gender, the proportion of acceptance, and then which school you're in. And we'll have successes and failures. All right, so let's go back here and look at the table that we're producing. So I used the same table, the table information that we just made, that goes in here. Depression is on the x-axis. Proportion, the proportion of nicotine dependence, is on the y-axis. And the fill variable is nicotine dependence. I just had a memory. Okay, we're going to see in a moment why we don't really like this plot and how to fix it. Okay, so we make some horizontal lines at 0 and 1 just to help identify where the tops and bottoms of the plot are. We do our bar plot. Stat identity creates this type of stacked bar plot where you put one bar on top of the other. And the rest of this is just sort of labeling. I'm going to facet the plot by sex, which means we're going to have two plots side by side, just like this was faceted by school. We had art on the left and business on the right. In our plot, we're going to have females and males. And we put the legend on the bottom just to so it doesn't take up so much space on the side. All right, so let's take a look. Did our markdown finish? It did. Okay, good. Let's go over and refresh our project file. And sorry, I just went up to the table of contents. Oh, it's taking a long time to load. Okay. Okay. That was a disappointing table. Oh, right. I know why it did this. Okay. So here is what cable will do for you. Nice looking table. Let's do that version. I have to show you this one thing in this code chunk let's stick with the table for a second. I believe, and we're going to test this in a second, that if you use the cable option, that you also need to, in the code chunk option, say result as is. That's why the previous table, this text version of the table, is all just mashed all together. Anyway, I think what I'll do is we'll just leave it like this. We'll have the nicer version, and I'll comment out just the text-based table. All right. The next thing is let's look at the plot that we just made and see if we like it. Looks like it needs to be a little wider. The title ran out of space, so maybe it is good to put the legend on the side. All right, so we've got depression on the, well, first of all, we have females on the left, males on the right. Okay, so sex is in the facets. Depression are left and right within each plot, no and yes. And then the proportion is the proportion of nicotine dependence. That's maybe I don't know, it's fine. And then the colors indicate whether they're nicotine dependent or not. Now I think it's sort of helpful here to let nicotine dependence be the primary feature of interest, and we would like that red, instead of being at the top and where you'd need to sort of subtract from 1 to see what that proportion is, it'd be much nicer if it started at 0 and went up. And so I think what we want to do here is we want to reverse the factor levels. And I think the way to do that, let's make this plot in our plot window over here. And I'm going to put that legend back on the side. That'll be fine. And the other thing I'm going to do is I'm going to set the figure height and width of this plot area. I just scrolled up to grab that code from a previous code chunk, and let's make this be a bit wider. Let's say 8. That would be fine. 8 inches. All right. I think that what we can do is, I'm going to look in, let's see, 4 cats, FCT. Okay, those are there. So I think that within there's a package called 4 cats, which is an anagram of factors, and the functions in that package allow you to work with factors. And I think what we want to do is we want to reverse. Let's look like the. I think we want to. This is sometimes useful when plotting a factor. Okay, and I think you can. So nicotine dependence, I think we want to reverse the order. All right. Oops. Yikes. Such a small window. There we go. Let's see if we get this to reverse. Oh, okay, so I did a couple things at the same time. Let me put that legend back on the bottom. All right, hang in there, guys. Let's make this bigger. I can't work in such a small area. Run this. And let's see. Okay, this is going to give us what we want. Let me zoom in. Now, the label for the legend isn't what we want, but blue is nicotine dependence, and that's at the bottom, counting up. So we got it where we wanted it. And, well, we don't know about the width. All right, I think that's pretty good. Let's knit this and write some interpretations. Okay, which I already wrote. I'll take you through what I wrote. So the way I got started with my interpretations, I went over to the categorical assignment, and I started using the language like this. Okay. And ours is going to be for females, and then for males, the proportion of people who are depressed have such and such a proportion of nicotine dependence. Okay, let's see if this finished our markdown. Yes. So we'll refresh. Okay, this plot's pretty good. It's a little bit wide. Oops. And but it's pretty good. We can also we can relabel the legend title if we wanted to. I'm probably not going to worry too much about it. All right, let's go look at our beautiful table. So for females, let's look. So we're going to basically restrict our attention to the rows where nicotine dependence. Okay. So for females who are not depressed, the proportion who are nicotine dependent is 7.6%. For females who are depressed, their proportion of nicotine dependence is 20%. Okay, so it's more than twice as much, almost 3 times as much. If you're depressed, you're much more likely to be nicotine dependent than if you're not depressed. Let's look at that for males. For males who are not depressed, 10%. So males are more likely to be nicotine dependent than females, 10% versus 7. And males who are depressed, their nicotine dependence is almost 27%. So again, almost 3 times as much for males. So I think the overall interpretation here is that men are more likely to be nicotine dependent than females, but if you are depressed, you're almost 3 times as likely to be nicotine dependent than if you're not depressed, and that relationship is the same for males and females. That's my takeaway here. Let's see if that's what I wrote previously. For females, the proportion of people without depression who are nicotine dependent is 0.076, while those with depression is 0.2, nearly 3 times as much. So the proportion of people with nicotine. It's a clumsy sentence. I'm admitting to it right now. Anyway, so both of these proportions are the proportion who are nicotine dependent. I think the way I've written this isn't very good. For females, let's do that. For females without depression, the proportion who are nicotine dependent is 0.076, while those with depression while for those with depression, that proportion, it is 20%, nearly 3 times as much. Okay, I think that's a better way of writing that. So for males without depression, the proportion who are nicotine dependent is 0.108, comma, while for those with depression, it is about 27%, nearly 3 times as much. And then I put it that general statement. Males generally are more nicotine dependent than females, but both are nearly 3 times more likely to be nicotine dependent if they are depressed compared to if they are not depressed. All right, very good. So I'll knit this, and let's see. Oh, was there something I wanted to do? This plot was a little bit wide, so I will just take out a couple of inches of width up here. Maybe 6 inches is just fine. And that's the entire assignment. So that's sort of where you can wrap it. I think what I'll do is I'll spend a couple minutes with labels. So if those of you want a better label on the axis down here, what we can do is, so you can label the title, subtitle, caption, x-axis, y-axis, and so on. In fact, why don't we label the y-axis proportion of nicotine dependence, and then the legend down here for the color is defined based on the fill parameter, and so that is I'll just call that nicotine dependence, and I think that should relabel it. Let's run this chunk of code. And see what we get. If we zoom, we can make it take more space. Okay, so nicotine dependence, that's the label I just applied to fill. The labeling the y-axis gave us the proportion of nicotine dependence. So this is looking like a better plot. And provided that, let's refresh this. Oh, I didn't refresh it since I changed the width. I think, you know what, if I shorten this by 2 inches, I think gender is going to get cut off. Another way to handle the title is to put in a /n, right? Move the words for each gender onto the next line. So /n puts in a line return. So I think that'll fix that up. Let's knit this, and then we'll call it the end. Do we want the legend to be on the bottom or on the side? Bottom's fine. That's a problem I have. I get real fiddly and picky about the way my plots look. All right, it's wrapping up. Okay, let's refresh it in the browser. Okay, so here's the contingency table. It looks nice. Here is the plot. Yeah, I think that's pretty good. I've got my title wrapping, and you can read all the labels. It could even be a little narrower, but that's done. I'm done. Oh, and then the interpretation. I've got the 2 bullet points, one for females, one for males, and then a sentence that pulls it together. So in your case, if you had only 2 categories, you'd end up with a single sentence, something similar to this. Recall that in the previous assignment, I phrased this a little bit different. I said for say the art school, the proportion of females was, I forget what it is, say 10%, which was 5% higher than for males. So rather than reporting the value for males, I reported the difference between them as the way to compare the females to the males. So either way is just fine. All right. See you in the next video.